Greetings to respected faculty. I am Lasya Mandapati from CSC AI&ML B section. My roll number is 24951A6686, and today I'll be talking about moving the operating system to the web. This idea comes from an IEEE article published in 2008, but it's still very relevant today. Normally, we think of our OS as something installed on our computer, like Windows or Linux. But what if the OS itself could live online and we could just log into it from anywhere? Well, that's what this talk is about. I'll explain what it means, how it works, its advantages, challenges, and what the future itself holds. Let's start with some background. The OS is basically the foundation of your computer. It manages hardware, memory, storage, and apps. Traditionally, it always lived locally on your machine, but over the years, we saw apps move online. For example, instead of installing Outlook, we use Gmail, and instead of Word, many of us use Google Docs. Well, this got people thinking, if apps and data could move to the cloud, why not the whole operating system itself? Well, a web OS is exactly that. It's like an OS you can access through the browser from anywhere at any time. So here's the key difference. A traditional OS is tied to your hardware. It controls your CPU, RAM, and files. A web OS, on the other hand, runs on a remote server. You open your browser, log in, and see a desktop-like interface. Your apps, files, and settings are all stored online. The upside is flexibility. You're no longer tied to a single machine. The downside is that it depends on internet connectivity. So, really, it's a trade off, local control versus global accessibility. Now, why even bother with this? Well, there are several strong reasons. First, accessibility. You can log in from any device instantly and get your personal desktop. Second, platform independence. It doesn't matter if you're on a Windows, Mac OS, or Linux, as long as you have a browser. Third, maintenance is far easier. Updates happen on the server side, not on your laptop. And finally, collaborations. Just like we share documents on Google Docs, a web OS could allow shared environments for group work. Basically, it makes computing more universal. A web OS has some unique features. It's a browser based. You don't boot into it like Windows. You open it through Chrome or Firefox. The client device is lightweight because the heavy work happens on a server. Apps are delivered as services, so you don't install them. And all your files live in the cloud, making them accessible anywhere. The main catch is internet dependency. If your connection is bad, your OX experience also suffers. The architecture usually has three parts. First, the client, your browser or tin device. Second, the middleware, which handles communication and security. And finally, the third, the server, which hosts the OS, runs applications, and manages storage. Each user's environment is isolated using virtualization. So, even though many people share the same server, it still feels like your own personal OS. This structure makes it scalable for millions of users. Virtualization is what makes this concept possible. Instead of directly exposing hardware, the server creates virtual CPUs, virtual memory, and virtual storage. This means the OS doesn't care what kind of device you're using. It just sees standardized resources. It also ensures isolation. So one person's work doesn't interfere with another's. Basically, virtualization gives you the feeling of a personal OS, even though it's running on a shared infrastructure. Now, resource management. In a web OS, resources are managed at the server side. Storage is cloud based and can scale up or scale down. Processing power is allocated dynamically depending on your workload. Memory is virtualized and securely separated between users. And load balancing makes sure servers don't get overloaded. The benefit is that even low-end devices can run heavy applications because the power comes from the cloud and not your machine. However, security is a major issue. First, authentication. You need strong logins, often multi-factor. Second, data privacy. Since your files aren't exactly on your device anymore, encryption is a must. Third, there are network threats like hacking or denial of service attacks. And finally, trust. You're basically trusting someone else's server with all your data. This is why security is seen as the biggest challenge for WebOS adoption. The biggest weakness of WebOS is the internet. If your network is slow, the OS feels slow. If the internet is down, the OS is unusable. Bandwidth and latency play a huge role in user experience. Some hybrid solutions allow limited offline functionality, but it's not the same as a local OS. That's why quality of internet service is critical if WebOS is going to work for businesses and regular users alike. There were some early attempts at this idea too. iOS was an open source web desktop. UOS offered a browser based OS with API for developers. Ghost called itself a global hosted OS. These were very innovative but limited by the tech of the time. Browsers were unpowerful, internet speeds were low, and offline support was poor back then. Still, they proved that the concept was possible and directly inspired things like Chrome OS and Windows 365 today. The advantages are pretty clear. You can access the OS from anywhere. You don't need a powerful machine, just a browser. Updates and patches happen automatically, so maintenance is minimal. Collaboration is built in, since everything is online. And for providers, scaling to millions of users is easier with cloud resources. In short, WebOS makes computing more flexible, portable, and user friendly. But there are still big challenges. Internet dependence makes means that you're stuck without connectivity. Performance gaps make it hard for heavy tasks like video editing or gaming. Security risks are also always present since data lives on someone else's server. And finally, user trust and adoption. Many people simply don't like giving up control of their OS. These are the reasons WebOS hasn't yet replaced traditional operating systems. The future, however, is exciting though. WebOS will integrate more with cloud platforms like AWS and Azure. We'll likely see hybrid models where some features run locally and others online. Security will improve with zero trust frameworks and better encryption. And as IoT grows, WebOS might become the universal layer connecting all devices across the world. In fact, we're already seeing this in Chrome OS, AWS workspaces, and Windows 365 Cloud PC. So the future is definitely moving in that direction. To wrap up, moving the OS to the web started as a radical idea, but is slowly becoming reality. Early systems like iOS proved the concept. Today, Chrome OS and Windows 365 show how far it's come. The benefits, accessibility, independence, collaboration are huge. But challenges like security and connectivity still hold it back. One thing, however, is very clear though. The boundary between local and cloud-based computing is fading fast. In the near future, we may not even notice where our OS lives. It'll just work anywhere, anytime. Thank you for listening to my talk. I hope you got a clear idea of what a web OS is, why it's important, and where it's heading.